Okay, I'll give you a little overview of what's going on here. Crank her up to 33. Oh, I don't know if you can see that very well. Get too close, it's too bright. There we go. 33 is that top line. Of course, it's going to be pretty steady now because I'm trying to video it. You can see it does go to the left, then go to the right, back and forth. If I go up to 45, it's a little more pronounced, and at 78, it just cannot settle down. Back to 45. Now back to 33. This actually measures about 0.4% wow with the iPhone app called RPM. The spec on this is 0.04 or 0.035, I think. So I'm trying to get to the bottom of this and see if I can do something about it or not. Okay, I'll give you a little tour of what the power supply levels look like. I'm just going to measure them for now, and then I will pull the scope out and let you look at the signals. So the plus 25, you can see it's wandering around. It's actually plus 26.7. This is not regulated according to the schematic, and I believe it. And you'll see the noise on it in just a minute. And the minus 25. Okay. And the plus 15, or minus 15. This one actually looks pretty clean on the scope. And the plus 15. And so these are regulated and have nice caps on them. I've checked these caps in and out of circuit. They're rated at 470. They actually measure around 560 with a very low ESR. I don't know if they're real electrolytics or there's some space-age technology from the 70s, but they're amazing. So I'm not suspecting them. I've even piggybacked on them to try to make them more effective, and it doesn't really help the 25. So these are for the 25 and not associated with the regulators. The regulators are associated only with the 15, and I assume these caps right here for the 15, which are just 47. That's the clean one. All right, so let's grab the scope on one more. There's a 4.7, I think. Where is that bugger? That's a cap. This guy right here. Oh, it's 1.5. Where's the 4.7? This guy right here. There it is. It's supposed to be 4.7. It's really closer to 4.5, but it is clean. All right, so I'll go over this one more time with the scope. Okay, I got the scope hooked up. It's at half a volt per division. Here's a look at the minus 25. Isn't that nice? It's got like 3/4 of a volt ripple on it. And the plus 25 is a little cleaner. And that's the plus 15. It's nice and clean. And minus 15 is also nice and clean. And yeah, the 4.7 or 3 is clean as well. Okay, here's a look at the tack signal coming back from the motor. And you can see it is varying. And of course you get the inverse of that signal on pin 3. So they come back on pins 1 and 3 of this little connector here. If you look at them at the same time, you can see they're 180 out of phase. So now look at the motor driver. This is AC. Basically seeing a switch point there, and on pin 4, yeah, that's what that looks like. So just to I've reread the brochure on this, and it never says this is a brushless motor. So I'm pretty convinced these are where the commutator or the brushes go over the gaps. And because this is really only sending 2 wires out to the motor, so if it was brushless it would have to send wires out for every pole. So this is not a brushless motor, even though it's 72 poles. So anyway, just looking at that is not confidence inspiring. It's my take. Alright, here's a look at the schematic. I'm going to look at all these waveforms here. Right now I'm hooked up to test point 1. Expect to find that waveform at the output of this op amp. Now this whole circuit in here appears to be related to the processing of the tack. So over here is the motor driver. This processes the tack signal. So we're going to look at test point 1. Got it hooked up right there. And that's what it looks like on my screen. I've got it set up the same way as in the schematic, 10 volts per division, 1 millisecond per division. And you can see it does open and close just a little bit. It is reporting the variations. If I go to a faster speed, no, it doesn't want to go to a faster speed here. Never mind that. So that looks, correct. I guess I expect it to be varying because it is varying. Okay, now I'm at the second test point. It should be another square wave starting when the other one stops, and it's the lower one here, so it's doing exactly that. So that all looks good, and even the levels look about right, except maybe this one's. Oh. Yeah. Even the level looks good. So, no problem so far. And now I'm going to go to test point 3, which is at the output of the next op amp. And let's see, pin 9, Z04. Okay, pin 9, Z04. That guy right there. And there's the signal. It's we're looking at it with still test point 1. So it should be going negative when test point 1 goes positive. And let me move it a little closer. Oh, it seems to be a little bit delayed. No, I'm sorry. We're looking at test point 3. Yep. So when test point 1 goes down, this one goes down as well, and then it builds up. So that all looks good. And finally, test point 4. Just down here. Let's see, 199 and 198. Okay, we're looking at test point 4 now. test point 4 and test point 1. So test point 4 should be going low when 1 goes high, and it should be coming up when 1 goes low. Should be back, and it looks like it is going low when 1 goes high, but it is coming up pretty soon, which is not what it's supposed to be doing actually. Let me just broaden that out a little bit. Yeah, it does seem to have kind of the right shape, but it doesn't last as long. Test point 4. I think I might want to check into that. Okay, I'm looking at signals 1 and 4 again. That's 1 up top and signal 4 on the bottom, and I've been trying to investigate why test point 4 is so short, because it's, according to a schematic, it should be rising up quite a bit slower, most of the width of that pulse on 1, and it bounces right back up pretty quick. Now 4 is on the collector of that transistor right there. I'm going to look at the base of that transistor, and interestingly enough, when that pulse goes high on 1, that's actually feeding the base, and it just takes a really small level increase there to turn that transistor on and cause that spike on the output. But you see how it kind of tails off. I'm thinking that probably the trailing edge, the output of that transistor, is not important. What's important is probably that negative spike. I hope. I can't rationalize how to draw that recovery out any longer. Okay, we're going to look at the output, and first thing I want to do is I'm going to look at the pins 5 and 6 on the input of this op amp, and 7, and I can tell you that they're fairly clean signals, but they do bounce around. So I'm going to look at them with the DVM first. Pin 5. That's pin 5, so it's got about 3 or 4 millivolts drift in it. Now I'm going to go to pin 6, which is the negative input of that op amp. That's also got about 3 millivolts, 3 or 4 millivolts on drift on that. So the input of this amp is being driven by about 6 millivolts of fluctuation overall. Well, let's take a look at pin 7. And that's varying quite wildly. That's like 10x, like 300 millivolts bounce. Now let's look at them with a scope. Okay, with the scope I'm looking at pin 6 again on Z103. That's basically the output of the speed control circuit, where your trim is and your speed selection stuff is. So that goes into pin 6, Z103, and you can see it's 2.7 something, and the variability is too small to see on the scope here, but it is fairly clean, so that's a good thing. And then pin 5, the non-inverting input, is also in the same ballpark, and oops, that's pretty clean as well. So, and here's the output of this pin 7, and you can see it has spikes on it that I'm guessing is some feedback from the motor. I'm not sure how it's getting to pin 7 because there's another output stage beyond this, but it's kind of interesting. It does have a wave to it. Anyway, we just looked at that. We've already looked at B4 and B2, the outputs here. I'll just review them. Take a look at B4 on the scope, and that looks pretty much like what we're seeing on pin 7. That's 1 volt to division, so that's somewhere around, 2 volts or so. And B2, which would be down here, kind of the ground, but it's not, it's floating around a little bit, a few hundred millivolts. That's ground right there. You can see it's not a solid ground. Well, it's not supposed to be. Anyway, that's what I can tell you about it. I hope if you have some ideas, you'll let me know what I can check next. And maybe it is something mechanical, or maybe it is the motor. That's gonna remain a possibility. Won't be much I can do about it if there is. That looks cool if you've seen those signals before and that's normal. Appreciate hearing from you. Thanks.